What makes large bodies of water so good at storing heat? Imagine standing next to a vast lake or the ocean on a chilly day. Even if the air is cold, the water feels warm and comforting. Why is that? It all comes down to how water holds onto heat. Large bodies of water are excellent at storing heat because of water's high specific heat capacity. This means it takes a lot of energy to raise the temperature of water by just 1 degree Celsius. Specifically, water needs about 4.18 joules of energy per gram to increase its temperature by 1 degree. That is much higher than most other common materials like soil or air. This high specific heat capacity allows water to absorb and keep a lot of heat without changing temperature quickly. When the sun shines on a lake or ocean, the water absorbs that energy slowly. It doesn't heat up rapidly like land does. Instead, it stores that heat for a long time. This is why large bodies of water can act like giant heat reservoirs. They soak up heat during warm days and releases it gradually when it gets cooler. This helps keep nearby air temperatures more stable. One reason water can store so much heat is because of its molecular structure. Water molecules are held together by strong hydrogen bonds. These bonds need a lot of energy to break or change. So, when water absorbs heat, much of that energy goes into changing the bonds between molecules rather than just raising the temperature. This makes water very good at holding onto heat. Another factor is the density of water. Because water is dense and has a high specific heat, the amount of heat stored per volume is very high. For example, 1 cubic meter of water needs over 4,000 kilojoules of energy to increase its temperature by just 1 degree Celsius. That is about twice as much as the same volume of concrete or rock. Water also circulates heat internally through convection currents. This internal movement distributes the heat evenly throughout the water body. It prevents the surface from heating or cooling too quickly. Plus, water remains liquid over a wide temperature range. It doesn't freeze or evaporate easily at typical environmental temperatures, so it can store heat over long periods. All these properties make large bodies of water perfect for moderating climate. Oceans and lakes absorb heat during hot days and releases it slowly at night or during cooler seasons. This helps stabilize weather patterns and keeps coastal areas more comfortable. Water's ability to store heat is also used in engineering. For example, thermal energy storage systems use water to help maintain comfortable indoor temperatures by absorbing excess heat and releasing it when needed. In essence, water's high specific heat capacity, molecular bonds, density, and ability to circulate heat internally make large bodies of water outstanding at holding onto heat. They play a vital role in Earth's climate system, acting like giant heat banks that balance temperature swings and support life everywhere.